Welcome to Review and Preview Problems in the CCG book 8-60 to 8-66. 8-60 says solve for x in each diagram below. So looking at letter A, I know that a triangle, all of the angles add up to 180 degrees. So 180 equals x plus x plus x, which when I combine my like terms equals 3x. So I can divide by 3, and 180 divided by 3 tells me that x is equal to 60. We're talking about the angles of our triangles, so we want to make sure that we say 60 degrees. Looking at letter B, I'm looking at a polygon that has 4 sides. I know that if I connect these two vertices, I have 2 triangles that equal 180. So 2 times 180 equals the sum of all of my interior angles. So 130 plus 102 plus 46 plus x. 2 times 180 gives me 360. When I combine my like terms on the right-hand side, I get 278. Inverse operation of addition is subtraction. 360 minus 278 gives me 82 degrees is equal to x. Looking at letter C, if I connect my vertices, I can tell that there is 4 triangles within my polygon. So 4 times 180 is equal to the sum of all of my interior angles. 6x plus 10 degrees plus 10x plus 8x minus 16 plus 12x minus 8 plus 7x plus 2 and plus 9x plus 4. When I combined all of my like terms, so on the left-hand side, I get 4 times 180 is 720. When I combined all of my x's, I get 52x. When I combined all my whole numbers, I get negative 8. The inverse of negative 8 is plus 8. 728 equals 52x. The inverse of multiplication is division. So when we divide both sides by 52, we get 14 is equal to x. So again, we're talking about angles of our polygon. So we want to notate that. When we are looking at question D, we have a polygon that is made up of 3 triangles, so 3 times 180, which equals 540. We need to solve for this variable right here. We have 2 parallel lines, so these would be vertical angles, which would make this side, because our lines are parallel, corresponding angles. So by adding our interiors, x plus 123 plus 90 plus 97 plus 113, and using our inverse operations, we get x to equal 117 degrees. 8-61 says, what is another more descriptive name for each polygon described below? A regular polygon with an exterior angle measure of 120 degrees. If I'm talking about an exterior angle measure of 120 degrees, that would make my interior angle measure 60 degrees. If I draw my polygon, or a triangle of my polygon, that would make my interior angle 180 minus 60, which would be 120. So to determine how many interior angles we have at 120 degrees, we take 360 divided by 120, tells us that our polygon has 3 sides, and a more descriptive name for a polygon with 3 sides is a triangle. And in this case, it would be an equilateral triangle. Letter B says a quadrilateral with 4 equal angles. So if we have a quadrilateral, it is a 4-sided figure. If we have 4 equal angles, the most descriptive we can say is that this is a rectangle. In order for it to be a square, they would have also had to have told us that they have 4 equal sides. A polygon with an interior angle sum of 1,260. Question C says a polygon with an interior angle sum of 1,260 degrees. So if all of our interior angles equals 1,260, we can add in our central angles, which we know equal 360. So if we add those two things together, we get 1,620. By doing that, I created all of my triangles on the inside. So I know a triangle is 180 degrees. So when I divide by 180 degrees, I get that there would be 9 triangles. So it is a 9-sided shape, which is a nonagon. Letter D says a quadrilateral with diagonals that are perpendicular bisectors of each other. So if we are talking about a quadrilateral, we're talking about a 4-sided shape. It says that the diagonals are perpendicular bisectors of each other. So they intersect each other at 90 degrees. So I know that this shape is a rhombus. 8-62 of triangle ABC is an equilateral triangle. If A is at 0, 0 and B is at 12, 0, then what do you know about the coordinates of vertex C? Prove your answer is true. So looking at the picture below, I could have a triangle that is sitting up, or I could have a triangle that is sitting down. Knowing that it is an equilateral triangle and AB is the length of 12, I know that my center is going to be directly above the ordered pair 6, 0. When I'm talking about an equilateral triangle, I know that all of my sides are equal. So if this side is 12 and this side is 6, I could use my Pythagorean theorem to see the distance of my other leg. So 12 squared is equal to 6 squared plus b squared. 12 squared is 144. 6 squared is 36. When I use my inverse operations and I subtract my 36, I get 108. The inverse of squaring something is square rooting it. The square root of 108 is approximately 10.39 units. So my other ordered pair would be at 6, comma 10.39, or it could be at 6, comma negative square root of 108, or negative 10.39. In the figure below, line segment AB is congruent to line segment DC. So our statement, if we're proving our answer, is line segment AB is congruent to line segment DC, and our reason or our justification for that is because it is given. They also told us that angle ABC is congruent to angle DCB. Our reason for that is also given. We want to make sure that we mark that on our figure above. I then know by looking at my shape that BC is congruent to line segment BC because of the reflexive property. Which I then can conclude that triangle ABC is congruent to triangle DCB because of side angle side congruency. Therefore, I can conclude that AC is congruent to DB because if we have congruent triangles, it implies that we have congruent parts. Letter B says, do the measures of angle ABC and DCB make any difference in your solution to part A? So looking at the figures, you can see that if we extend A and D out, it makes our angle skinnier, but AB is still congruent to DC. This angle is still congruent to this angle, and side BC is a reflexive side. So it doesn't matter which way we adjust our figures, we could still prove these triangles congruent. 8-64 says, on graph paper, graph the parabola y equals 2x squared minus x minus 15. What are the roots, which are also called the x-intercepts of the parabola? Write your points in xy form. And B says, how would the graph of y equals negative 2x squared minus x minus 15 be the same or different? Can you tell without graphing? So if we want to graph a parabola, there should be some things that we remember, and a variety of different ways we could do this, thinking back to Algebra 1. Looking at this quadratic in standard form, hopefully I remember that negative 15, or my C value, is my y-intercept. I could then use a table if I absolutely forgot everything I know, and I could plug in random values to get the shape of my parabola, or I could use factoring, the quadratic formula, or completing the square to solve as well. So the method that works every time is the quadratic formula. If you list your A, your B, and your C, so the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So when we simplify this out, we get 1 plus or minus the square root of 121 when I combined everything underneath my radical, all over 4. So I get x is equal to 1 plus the square root of 121 is 11 over 4, or x is equal to 1 minus square root of 121 is 11 over 4. When you combine your like terms, 12 divided by 4 tells us x is equal to 3. And negative 10 divided by 4 is x is equal to negative 2.5. So it's said to write these as an ordered pair. So our x-intercepts are 3, 0, negative 2.5, 0. You can plot those on your coordinate plane. And you can see that our graph or our quadratic would be opening up. When we look at question B and we have this negative in front of our quadratic is going to be the exact same shape, except it is going to flip over our x-axis and open down. (8-65) is a multiple choice question. To decide if his class would take a quiz today, Mr. Chiu will flip a coin 3 times. If all 3 results are heads or all 3 results are tails, he will give the quiz. Otherwise, his students will not be tested. What is the probability that his class will take the quiz? So when we take a look at this problem, the chances of his first flip are a 50% chance that he will get heads or a 50% chance that he will get tails. We then need to do our second flip. We have a 50% chance again that we will get heads, a 50% chance for tails, 50% chance for heads, 50% chance for tails. We then have a third flip. If it landed on heads, 50% heads, tails, 50% heads, tails, 50% heads, tails, 50% heads, tails. So we said we needed to get, in order to take the quiz, he would have to get 3 heads in a row or 3 tails in a row. So the chances of flipping heads 3 times would be 0.5 times 0.5 times 0.5. So likewise, with flipping the tails 3 times, we have 0.5 times 0.5 times 0.5. So both of these equal 0.125. And either scenario will cause him to give the quiz. So we need to take the probability of flipping tails 3 times and the probability of flipping heads 3 times and add those together. So if we have 0.125 plus 0.125, that gives us 0.25, which is a 1 in 4 chance that they will take the quiz. 8-66 is another multiple choice question. It wants us to approximate the length of AB. I notice that I'm working with a right triangle. I'm given an angle, I'm giving a side length, and I'm missing a side length. So I can use right triangle trig. This 27 is the side opposite of my 54. This x is the side adjacent to my angle 54. Tangent uses opposite over adjacent. So if I plug in the tangent of 54 degrees, I take my 27 and place it over my missing side. Use my inverse functions. X times the tangent of 54 degrees equals 27. Divide by tangent of 54. I get the side of my triangle to be approximately 19.62 units.